but I labeled it currently. The working title was Stop Listening to Me. Misadventures, then in bracket, misadventures in concurrency. Make asynchronous code work for you, not against you. The reason I'm here was at the Android Social Night. Jeff heard me talking about a problem had, and I was working through it. He goes, great, you can do a lightning talk on it next month, so that's why I'm here. So,
it's that easy.
Yeah, exactly. Thanks, Jeff. Sort of the problem, take code based on the Firebase APIs and make it conform to an application architecture pattern. For instance, I pulled this right out of the Google Firebase documentation. The big little sort of, it seems pretty simple here, but the real sort of, oh, that was supposed to be, is are the listeners. Because Google, a lot of the APIs, a lot of code, Google uses it, we see it all around. They use the listener pattern, so they actually have an asynchronous call, and then when it's done, we have a listener to figure out what we're going to do, which, you know, fairly simple code. I made just a sort of a simple app example. It seems pretty simple. Let's take a string on an edit text and save the data to Firebase. It's not rocket science here. We have a little lambda for the on-click button for the listener. That takes care of all of that, which, you know, for a small little app such as that, pretty easy. What's the problem? And the problem, the business rules, the presentation, and the model is just all embedded in that one lambda. Well, yeah, if all our app is just one edit text and one button, cramming everything into the lambda is going to work really well. The problem is that if we have more complicated apps, we just can't have all these little lambdas and everything scattered around. We can't be doing massive godlike activities and fragments. We need to architect our application. The goal, structure an app using an architectural design pattern. I picked the MVVM because that's the one Google's plugging. Some of you may say MVP, some of you may say MVI, but the whole thing is we're structuring our app and going to get away from the godlike activity patterns. Sort of what are the goals for the model? Regardless of what model we use, we're looking for utilize clean architecture design principles. When I say clean architecture design, I'm referring, of course, to Uncle Bob. If you haven't heard of clean architecture before, just Google clean architecture. First thing you're going to read is his essay. I think it's mandatory reading for all of us. The big takeaway from that is the dependency rule. All our dependencies should point inward, so you go sort of your view model down to your data, and it shouldn't be going backwards. You know, the model should be data store agnostic, and the model should be reusable. The model should be data store agnostic. That means whatever model we have, how it's actually implemented doesn't matter. We could do Firestore, we could do shared preferences, files, realm, room, SQLite, whatever, but it doesn't matter. The actual application doesn't have to matter, because what happens if next year Google decides, oh, we're not going to support Firebase anymore? You're like, well, now what do we do? Now you got to go through all your app, find where all the code's scattered, and try to re-implement it in something else. But if we can put it all in just sort of one little neat little package, that should work. And also, when I say model should be reusable, your model really shouldn't care whether it's ideally an Android or an application or something. We should be able to reuse it. Sort of, so like what's the problem? Well, when we have all these listeners and we go to these architectural design sort of patterns, we're going to no longer have, we're going to have our model is going to have all these listeners potentially scattered throughout them. And then when the listeners are firing, because they're all going to be happening asynchronously, do we have our listeners going back to, say, our view model, our repository? Do the listeners talk to the other listeners here before they go back to the view model? Like, what kind of pattern do you set up? It just kind of gets real messy real quickly. So this, I sort of said to anybody listening, it's a pretty simple code example where straightforward. It looks simple. Like assume, so basically we're looking to figure out if a user exists. Does the user have a record in the Firestore? So we check to see we have it, and if the user If we can find the user, then we return true. Otherwise, we assume they're not there, false. Seems simple enough. However, every single time you run that, regardless of whether the user exists or not, it will always return false. Because it's going to happen if this little gotcha. Because what will happen here is, well, it's going to get the document. The rest of the code's going to continue on. We will return false because we're in here. And then this will execute, but there'll be nothing there to listen to it. As I said, this quite illustrates one of the best things about asynchronous code. You know, is also the worst thing about asynchronous code. It's great that it sort of runs in parallel. It's also bad that it runs in parallel. So, so what we can do, obviously the one easy thing to do to get around this is we'll do callbacks. Got that, you know. So how do we handle it? So we'll call our is the user listening, and once we finally get here, we'll call back to in this case the view model, say whether it's true or false, and we'll have a method to figure it out, and away we go. Not too hard. And we're done, because we're going to have a view model. It's going to go to the model, and then eventually the Nixlers are going to call back. Nothing more to do here, except, or are we done? Because one of the issues with callbacks is they don't scale very well. You know, if all we have is one method that will check something and will call back, that's great. But the more things we have, the more callbacks we're going to need, and eventually it's like our code's going to become a mess if you're trying to trace through and problems go wrong. Is the code, you know, where we start in the model or when it calls back, trying to trace everything through is a nightmare. And we have a word for that. It's called Callback Hell. Cute little thing. This is, you know, I'm sure for many of us too. I illustrated. You know, this is actually this was an actual Sesame Street character, but I'm sure for many of us, when we're debugging and we soon realize that we're dealing with a concurrency issue, step one is bang your head on the keyboard. But so it's like, well, what do we do? Because the callbacks aren't going to work. Because really, what we're doing with the callback is we're taking we're sort of taking what's sort of an asynchronous or a reactive problem and applying an imperative solution to it. So that said, if we're dealing with something that's reactive, then why not use a reactive solution? So we'll treat those, so all those listeners that we have, view them as reactive events. So we call something, and then when eventually the listener's done, we'll handle them in a reactive framework. For this one, we're using RxJava for this example. So the advantages of using sort of the reactive solution are it sort of manages asynchronous code in a predictive fashion. We don't need all the callbacks. We just listen to all our code to let us know when it's ready. It abstracts the model implementation. We don't have to, whether we have a reactive, let's say in this case a Firebase solution, or whether it's a reactive room solution, doesn't matter from our code. And it implements the dependency rule, because all our model, through getting calls and returning reactive events, we can basically drop it anywhere, and there's no callbacks. We could replace it with another bit of code. So, you know, like we have to think too of like when we think of RxJava or reactive code, we typically think of observers. But if you're refactoring your code, also remember we have other things like such as the singles, the completables, and the maybes are there to help us out. So what types of observers? The other thing too we consider with the observers is it's not just an observer, we can chain them together. So in order to, so instead of trying to figure out what calls what and all these chains, we can put everything sort of just in one little bit of code. You know, flat map is a great tool for helping to piece together your observables. So how do we refactor? The previous example, well here, we return a single Boolean. So we change that to, instead of Boolean, it becomes single Boolean. We want to return single.create. Then we have a lambda. I'm using Kotlin here for this example, but it can be Java equally well. And then here on our .get, and then in the success listener, we emit single.onSuccess if it's true. We emit single on success if it's false. In the event we have a failure or whatever with our data store, we can emit a error event. And then how do we use it? This one here, we actually, so we'll actually call our observer. I'm using here a flat map that will determine if it's Boolean true false, what the next step is going to be in the workflow, and then depending on the workflow, it figures out whether we need to update something on the view or whether we need to grab more data. And the last thing we do is take our observer and add it to a composite disposable at the bottom. So an example here, this is actually the thing from the, let's see if it, we can work here. It's actually from the, well, what's supposed to happen here is, it does it, obviously, something, this is going to be the cool thing where you got to see how the app works. Pardon?
Can you click with the mouse?
Yeah, let's see.
Yeah. Oh, no. Right there.
No. Well, why didn't you? Well, let's stop playing. Let's sort of play a walkthrough here. What's going to happen is, what the app does is it will actually scan a barcode. Once it scans the barcode, it will figure out what the book is and add it to the list. Now, this book here, it's supposed to disappear for a moment. You're going to see my cat here. So you just have to, visualize everything here, and then we'll do it. Then we'll take a picture, scan the ISBN number, and then you'll discover that the book I'm scanning is the Gang of Four book on design patterns. So what would it actually sort of look like? This is sort of a more complicated example here of how I manage it. So what has to happen here? We start with using the Firebase Vision, which takes a bitmap. Once it has the bitmap, it'll grab the ISBN number out of the code. I do an analytics thing here, where basically I say I report that we scanned a book. There's a code here to Google Books that actually figures out what the book is. Then we write the book to Firestore. Then we add the book to the user, and then we figure out all the books that the user has currently read, and we update the view. We emit a SEO class in this case with all the updated books, and the user on the app is going to see all the books that they're currently reading, including the new book that they just scanned. And then if there's an error, we'll emit an error to our camera view. And then last thing we do is we use a composite disposable, so we can keep track of all our disposables in the end, make sure everything's all wrapped up. That's what's supposed to happen, but that's sort of the chain that you're looking at. I use this sort of just another tool because obviously some people say, well, Kotlin has other features. Well, we can do other things in Java. That's the great things about architecture, is there's many different ways to do this. We can all argue over which is the better. But I use the example of all these screwdrivers. I view, for instance, if you're in the Java world, you're probably better off using all the Reactive RxJava. If you're not in the Java world, maybe not. Maybe you want to do the Kotlin. This is just sort of one pattern. I think we should look at it more of a tool to add in our toolbox that might work under certain occasions. Because let's be honest, we've all looked at something and said, I would never do that. That's stupid. I know how to do this. And then, a month later, oh, I really love this. I can't believe I thought it was a bad idea. So, sort of that. So never say, this isn't, I wouldn't say, oh, this is the be-all and end-all of how you should be implementing your models, but it might, for depending on what you're doing, it might work really well. If you have data sources, for instance, like a network-based Firestore database, this would handle it really well. So, as I said, like for instance, with the screwdrivers, and it might, so just sort of add it, put it in the back of your head. Just sort of on the subject too of, I think everybody at some point will say, I don't know, we all have some idea of where we are in Reactive Java. Some will say, I don't. Some people will say too, oh, what's Reactive Java? We'll use all coroutines, right? RxJava's dead. Let's use coroutines. Whatever, it's just another tool or whatever. As I said, to keep in your toolbox. that's what beer's for afterwards if we want to argue over RxJava versus coroutines. But just sort of on the subject too, if you are, for instance, you would like to increase your RxJava knowledge, I forgot to include it in the slide, but if you have your Toronto Public Library membership, there's a great book through Safari Online, or you can buy it on RxJava, which sort of explains everything you want to know about Java. Lynda.com too has a great thing on doing RxJava and Android, but it's all in Kotlin, so it introduces all the stuff. It's a crash course in RxJava in different ways to implement it. And on that note, I just want to say thanks for listening and keep coding.
Thank God the cat GIF worked.
Yeah, I know. As I said, the thing with you younger kids is you relate to all these GIFs. So I had to put a few animated GIFs in.
GIFs are the great.
Yeah.